In this video, we're going to start talking about section 3.3, which is, the title of it is Implicit Differentiation and Related Rates. In this video, I'm really just going to explain to you what implicit differentiation is. We'll talk more about related rates in class. Implicit differentiation is basically differentiating a function that has multiple variables. So basically what you're doing is you've got a function with x and y in it, such as x squared plus y squared equals 1, and you're asked to differentiate that, find dy dx. So one thing you need to note is that dy over dx means the derivative of y with respect to x. So that means you basically want to find dy dx is the derivative of y in terms of x. So you want your variable to be x in that function. So if we're going to differentiate x squared plus y squared equals 1, x squared is already in terms of x, so you don't have to differentiate that any different. But y squared is in terms of y. So we're going to look at y squared as a function of x. And so we're going to look at it as kind of a composite function. So the way that we're going to differentiate this is we're going to go ahead and take the derivative of x squared, which is 2x, and then we're going to take the derivative of y squared as if it were a composite function. So the exterior of y squared is just going to be 2y. Now, we took the derivative of the exterior of y squared. Now the interior of y squared, which is in terms of x, we're going to just call that dy dx. So that we're using the chain rule. We're taking the derivative of the exterior of the function and then multiplying it by the derivative of the interior of the function. The derivative of y in terms of x, we don't know what it is yet, so we're just going to call it dy dx, if that makes sense. And then the derivative of 1 is just going to be 0. So the whole purpose of this, dy dx is an unknown. We don't know what that is. So now we want to solve for dy dx. So now we're going to move everything to the left side. So we're going to get 2y dy dx is equal to negative 2x, divide by both sides by 2y, and so we end up with dy dx is equal to negative x over y. So the derivative of y with respect to x in this function is going to be negative x over y. I know it's a little bit hard to process, but once you work a couple of problems, it starts to make a little bit more sense to you. So, I have a couple of examples here. First example is y to the 5th minus 4x to the 4th equals 3x. So again, what we're going to be doing, we're finding dy dx. So we're finding the derivative of y with respect to x. So, in this case, we've got y to the 5th. So again, our exterior function is going to be 5y to the 4th. And the interior function, the derivative of y with respect to x, we don't know what that is, so we're going to call that dy dx. Minus derivative of 4x to the 4th with respect to x is easy. That's just 16x cubed is equal to 3. So again, we're going to isolate dy dx. So we're going to say 5y to the 4th dy dx is equal to 3 plus 16x cubed. Then divide both sides by 5y to the 4th. And we get dy dx is equal to 3 plus 16x cubed over 5y to the 4th. Do you see there's nothing that really we can cancel? So the derivative of y with respect to x in this function is 3 plus 16x cubed over 5y to the 4th. And then the last problem that we're going to work is has a little bit more to it. It uses the product rule. So well, first let's go ahead and find the derivative of this. Again, we want to find dy dx. So we're going to find the derivative with respect to x. So our dy dx here is going to be 2x plus, and now do you see that we have to use the product rule here? Let's consider this our u, and then we'll consider the y our v. So u is going to be 4x, v is going to be y, u prime is going to be 4, v prime is going to be the derivative of y with respect to x. So it's going to be the derivative of y is going to be 1, right? But then we multiply that by dy dx. Okay. So if we use our uv formula, we'd say uv prime plus vu prime. This is going to be u, which is 4x, times v prime, which is dy dx, plus v, which is y, times u prime, which is 4. Okay? Then plus, now we're going to do 4y here. The derivative of 4y is going to be 4, but then we still have to multiply it by dy dx because it's in terms of y, is equal to the derivative of 1 is just 0. So again, now we have to simplify. 2x plus 4x dy dx plus 4y plus 4 dy dx equals 0. So let's get everything without dy dx on the other side. So we'll have 4x dy dx plus 4 dy dx is equal to negative 2x minus 4y. And now do you see we can factor dy dx out? If we factor dy dx out, we're left over with 4x plus 4 inside the parentheses. And now if we divide both sides by 4x plus 4, we get dy dx equals negative 2x minus 4y over 4x plus 4. So that is the derivative of y with respect to x in this particular equation. So I hope this makes sense, and let me know if you have any questions. Good luck with the prep quiz.